In a recent poll on Twitter, 66% of you said that when you heard React Server components for the first time, what you heard was a component that worked just like a client component, but where when you changed the properties, it would go off to the server, asynchronously create a new component for you, and then slot it in to where that component was in your tree. It was a component that was just rendered on the server. And what we got with Next.js 13 was not that. But it turns out that the RSC support that's built into React actually supports multiple models of React Server Components, or RSCs, and we're only seeing probably the most conservative one in Next.js 13. What Remix is going to do with RSCs is still up in the air, and there's this really cool new framework from Dai-shi Kato, the guy that gave us Jotai and Zustand, called Wakuwork, and it actually shows some very different models of using RSCs that provide a much better developer experience. Now, of course, none of this is ready for prime time, including Next.js 13's app router directory, which is still in beta. But I think there's time to make changes or add on additional RSC functionality to Next.js so that we can have it there as well. Anyway, enough talking. If you're into React architecture stuff, you're going to love this video. Stick around. Let's get into it. This is the example application that we're going to build 3 different ways. Once using Next.js 13 and then 2 times using Wakuwork. It's a very simple e-commerce system. It has a jacket selector color here, and then you get some additional things. Like, for example, if you like a blue jacket, you might like a blue collar or a blue harness or a blue leash. And you can add those items to the cart. Now, besides the cute dogs, the most important thing visually about this example are the border boxes around the different components. A red border box indicates that this is a server component, and a green border box represents that this is a client component. And this example that we're looking at right here does the unfathomable, the unthinkable, the terrible component weaving, which means that it's got as the outer boundary a React Server component, and then nested within that a client component, which is then nesting a React Server component, again, a no-no, and that React Server component does a triple no-no of bringing in client-side components. So, this is apparently a terrible example, and yet it actually still works. And this is the last example that we are going to do, so stick around and you'll see how this is done, and it's actually really, really cool. And then I'll talk about why pretty much every framework author will tell you that this is a terrible idea. The first thing we're going to do is build up the Next.js 13 version of this. And the idea is to give you a reference point, something you understand and you're familiar with, so that as we look at Wakuwork and compare the different solutions together, you'll have a good reference point. Here we have the project in VS Code. All of this code is available to you on GitHub for free, as always, in a link in the description down below. And the first one we're going to be taking a look at is the Next.js 13 version. So I'm going to bring that up right now by doing pm dev. And what we can see in this version is that we don't have that carousel at the bottom. And that's the thing that we're really going to focus on in this example, is the implementation of the recommender carousel, because we want to be able to have some different options on implementing that. Now in the Next.js version, that's going to have to be a client-side component, and it's going to have to make a call out to an API to get that data. So the first thing we need to do is establish that API of recommendations. All right, in Next.js 13, in the source directory under app, we're going to go and add a new directory called combinations. And then within that, we're going to create another folder called color within brackets. And that's going to take the color choice and give us back the JSON payload that has the products that are appropriate for that color of jacket. So a blue jacket is going to give us a blue leash, a blue harness, and a blue collar. So into this directory, I'm going to create a route.ts file. And in there, I'm going to paste in an implementation, and we'll just go through that implementation. So we're going to respond to a get verb. This is the new app router version of API routes. You just specify the different route verbs like get, post, delete, patch, update, all of that. And then you give the responder. So in this case, we are going to make a request back to ourselves to go get a file called whatevercolor.json. So let's go over and take a look in the public directory. And here we have all of our assets, like our collars, our harnesses, all that. But we also have these JSON files. And the JSON files have a pretty simple layout. They've got the array of the different products with the names and the thumbnails. Now, what I'm trying to imitate here is that you have a back-end microservice somewhere that's giving you this. Now, I don't want you to have to deploy multiple servers to imitate that. So I'm just going to use the public directory as effectively like another microservice. Just think about it that way. Don't think about it as, oh, I could just make this request off the client. It's so much easier. No. What I want to show you is that you need to make a request from the client back to its own Next.js server in this case. And then that Next.js server is going to make the subsequent request to that microservice. And that's what we've got here. So we're just going to make that fetch, and then we're going to return that JSON response. All right, so let's go make sure that this works by going over to our arc and then bring up a new tab and then trying out combinations and blue. Perfect. That's the data that we're looking for. Okay, so now we need to request it because we have a product carousel ready to go. It just needs the data. So to do that, I'm going to go over to our store.ts file. And what we currently have in the store are a set of Jotai atoms. And these are atomic state values that you can then subscribe to, and they're held globally. If you're not familiar with Jotai or Recoil, that's okay. Let me just walk through one example to kind of show you how this works. So we have a color atom here. We initialize it with green in a custom hook called useColor, and that useColor returns the string value currently as well as a setter, kind of like useState. So if you take a look over here in the components, in our jacket color selector, when we bring in useColor from the store, we destructure that tuple into the current color, and then we get a set color, and we use it just like anything else. For example, in this case, we're just connecting that to our selector, then doing an on change, and that's it. And so anything that can listen to the useColor at that point is going to get the new value of that useColor. Okay, let's go back to the store. Now, there's two reasons why I wanted to use Jotai for this example. The first is that it supports asynchronous atoms. That's an atom that goes off and makes a fetch or does something asynchronous and then sets its value based on the result of that. The other reason is that Jotai, like Recoil, allows you to create dependencies between atoms. So for example, we can create a combinations atom that looks at the color atom, and when the color atom changes, goes off and fetches the combinations for the color asynchronously from the endpoint that we just created. So to do that, I'm going to bring in some code. In this case, atom is a promise, and that promise promises to give you back an array of objects that have the name and the thumbnail. Then instead of giving it a value like we do up here with green, we give it a function. In this case, an async function. And that async function gets a getter as the first parameter. And then with that, we can get the current value of the color atom. And we can use that to make a fetch to our combinations and then return back the resultant payload. Now, this is a read-only atom. There's no way you can set this atom. So what we should do when we use it is to use its value and not return a getter. So to do that, we can use atomValue. And then we can just export a useCombinations that uses useAtomValue on that combinations atom. And we can take that and bring it over into our product carousel, where instead of just assigning combinations to an empty array, we can instead use that useCombinations from the store. Okay, so it looks like the data is showing up. And if we change this color, we get the new values. Whew, that is sweet. That is Jotai. That's why I love Jotai. And then I can add to cart here. And let's just go into how this works after we did this useCombination. So down here, we have a client component. It's going to go through all the combinations, do a little bit of CSS magic to kind of lay it all out pretty nicely, put on an image, put the name, and then put in an add to cart button. And that add to cart button is in itself a client component. You give it a product, and then it has a button on it. And when you click on that button, it uses the set cart value that it got back from useCart, which is again correlated with that Jotai. There's a Jotai atom called cart atom that this is getting and setting, and it just appends the product to the cart. Okay, so that's the Next.js 13 standard implementation. We have a layout that is a server component. It includes this jacket color selector, which is a client component because it uses hooks, in this case the Jotai hooks, to go and set the values. And then anything nested within that, regardless of if it uses hooks or not, is going to be a client-side component. So that's red on the outside, and then at some point, you're going to go green, and everything within that nested is going to be green. Now, the next version of this that we're going to look at is a Wakuwork version that uses actions to create a much easier backend for front end, where we had to go create our own combinations, color, get route. It's going to do all of that for us really easily. Let's go check it out. This first Wakuwork version of this is in the Wakuwork server functions directory. So what is Wakuwork? Let's just cover that for a second. Wakuwork is essentially like a Next.js 13 competitor, but much more minimal and created by Dai-shi Kato. So it's pretty cool. So let's go ahead and try this out and see how it looks. And we're back to where we were before at the starting point of our Next.js 13 exploration. We have a RSC layout, and then within that, we've got a client component that has the jacket selector. We can select different jackets. It uses Jotai for all of this as well. We're just missing that product selector. So how are we going to do this? Well, what we need is we need to create, again, that API that's going to make the backend fetch to our microservice. In this case, again, hosted in public, but it's still that microservice concept. So let's see what we have in our Wakuwork application currently. We have an index.tsx that starts up our app. We give it a name, valued customer. That's where this header for valued customer comes in. And then this app includes the header at the top, the key down here at the bottom for the server component, client component, and then it has the jacket color selector, which is the client component. And pretty much from there down, it's exactly the same. So this is going to be our root index for our application. Now, what we really want is we want this product carousel to get those combinations. We get the color in. Now we need to make a fetch to our local server that will in turn make a request to the microservice that will go get us those combinations. So the first thing we need to do is implement that server side of the fetch to the microservice. To do that, we create a new file called fetchcombinations.ts. And here's the implementation. So we have use server here at the top. That's going to tell Wakuwork that this is only on the server. This function resides only on the server and should be run on the server. That's why, for example, we have an absolute URL here to localhost 3000 because we're on the server. We need to know what host we want to get that data from, and it could be any host anywhere, including a microservice. It's going to be us at this point, but that's not the point. Okay, so we're going to make that fetch, and that's going to give us back our combinations. Now, in order to use that, we're going to go bring that over into our app. So we're going to bring in fetch combinations, and it's important that this be brought into a React server component, and then we're going to pass this through to our product selector. So the first thing we need to do is send it to our jacket selector, since it wraps the product carousel. Of course, it doesn't know that it's coming, so we need to go and add that. And then we need to pass that on to our product carousel. Of course, it doesn't know that it's expecting that either, so let's go and grab that and then take it over into product carousel. And then we'll just add that in on top of the color that we already have. So now we have fetch combinations, this server-side function routed through the React server component, which is the app, through the client component, which is the jacket selector, through the product carousel. Now we just need to call it. To do that, we're just going to use a combination of useState and useEffect. Pretty standard stuff. So we're going to have some useState that has the combinations, and then we're going to have a useEffect that's going to make that call. We'll start off with the useState. So we'll define that down here for our combinations. We're going to say the combinations is an array of the name thumbnail objects. And then in our useEffect, and this is where it really gets fun, we're going to do fetch combinations as just a function. We're just going to call fetch combinations as if it's a local function, when in reality, it is actually going to make a post request back to the server. So let's go see that. Okay, looks like it worked. So let's actually see in the inspector how this is all coming together. So if we go over here to network and we change green to blue, what we'll see is that we have done this action. We called localhost 3000 RSC underscore action ID, and then we give it a payload with an array where we have blue is the first item in there. So basically that's the arguments going to that function. And then the response that we get back is an array that has all of our data in it. Pretty cool, right? Now the big win here is that we didn't have to write that backend for front end. We didn't need to go and create our own API. All we needed to do was create our function, in this case, fetch combinations, and correctly route it through from the React server component to any child component that wanted to use it. And then it could use it just like any other function. And you can do this both for fetches as well as mutations. Now, I learned how to do this by looking at the Wakuwork example code. I definitely recommend that you read that code if this is interesting to you. And I put a link to it in the description. Now, this isn't the only framework that implements this. If you're interested in a closer to production ready version of this kind of automatic backend for front end creation, you should go check out Quick, which has a server function in it. And you can simply just define the function that you want run on the server right inside of your component. And it does it all for you just right there, which is super cool. And I would say the DX or developer experience on that is better than what I'm seeing here. But that's not where Wakuwork ends. It ends at a very interesting place, which is much more in line with the React server component implementation most of you thought that you were going to get, which is a component that you simply change the properties on and get new content from. Turns out that React 18 has streaming functionality that can be reused in a way to make that happen. So let's try that out. So this example is over in Wakuwork RSCs. So let's fire that up. Now we're back to our starting point again, just like where we were with Next.js 13 and the original Wakuwork example. But this time we're going to do something really different. We're going to turn our product carousel into a server component. So we're starting out with a product carousel that looks eerily similar to what we had before, with two exceptions. One, we've defined it as an async component, like you have done with React server components before on Next.js 13. That means that you can make fetches or whatever you want in this preamble section up here. And we brought in a server component and wrapped it in a server component so it gets that nice red border indicating that this is a server component. So how do we make that fetch? Well, again, remember, this is running on the server. So when it's running on the server, it can make that fetch directly to our microservice. So that's what we're going to do. We're going to bring in fetch combinations right here. And that's going to call our microservice. Again, it's running on the server. This is okay. And then down in here, we're going to say that our combinations are just awaiting the output of our fetch combinations for the color that is given. So now we need to bring in our product carousel into our jacket color selector. To do that, we're going to bring in a function called serve from Wakuwork client. And then we can invoke serve and give it the string name of the component that we want and the properties that go to that component. Now we have a component here, but it just happens to be a server component and not a client component. Now, one thing we want to do is make sure that we only use product carousel when we're mounted on the client. So we need to track whether we're mounted or not. To do that, we create some state called mounted and then have a set mounted, and we use effect to say that we are mounted. And then we need to add our product carousel. So let's go down to the bottom of our layout here and say, if we are mounted, then put a product carousel on the page. Let's try it out. And it doesn't work. So let's go see if we can get some information from our console. So it's telling us that we have a 500 on product carousel, which probably means that it can't find it. So what we need to do is we need to go over here to our entries file. And we can see that we actually have some interesting entries here. We have app, which is returning the import of source app. What we need to do is add a corresponding one for the product carousel. And then also down in the prefetcher, add a prefetcher for the product carousel. We just prefetch it with green. And I think that should work. So let's give it a try. And there we go. Now we have our carousel, which is a server component, embedded in our client component, which is the jacket selector. And now when I hit add to cart, even though add to cart is a client component, it is nested within a server component, and it still works, still talks to the same Jotai global store, and everything works just great. Let's go over to the inspector and see what's actually happening underneath the hood. So if we go into network and I change, for example, green to blue, we can see that we get this interesting request. We get RSC, and in this case, product carousel. Then we get the props. So in that case, it's the color blue that we just requested. And then we get this interesting response. And this interesting response is what we see when we use streaming in React Server Components. It's basically saying, make these changes to these points in the DOM, even though that component doesn't exist on the client. So this is exactly what I think folks were thinking about when they were thinking about React Server Components. The jagged color selector, in this case, changes that color, and that forces product carousel to update, even though product carousel is an async component that actually resides on the server. And it can do all that cool async React Server Component stuff that a React Server Component can do. Now, I find this version of React Server Components to be very compelling. If you're on the server, you can make server requests. If you're on the client, then you can go and have hooks. It's really nice. So why aren't we going to get this? Well, I've talked to a couple of framework authors, and the reasoning is this. When you have a server component nesting a client component, which nests a server component, you have effectively what they call a potential for a waterfall. And the idea is that if the nested server component or client component ends up changing the state, then you can get into an infinite request loop as you get new server components that in turn have new client components, and they cause a state update and so on and so forth. And you can get an infinite loop, which is ironic since this isn't the first foot gun that we have had in React. In fact, useEffect is a notoriously bad foot gun for creating infinite loops. So why this particular anti-pattern is so much worse is not clear to me. That's why I made this video and these examples and why I want to start this conversation. Do you like the NextJS 13 version with the RSCs that they have? Do you like the Wakuwork extension where you can just create actions really easily and get those as well? Or in addition to all of that, do you like this kind of nested RSC style where the components act just like components, they just happen to reside on the server? All of these models are still available to us. NextJS 13 is still in beta, and they could add these additional features if they wanted to. So let's start a conversation about that and see what you think in terms of the architecture that you want for React Server Components in NextJS 13 and also in other frameworks as well. For example, Remix could be another one that is also in the process of developing their React Server Components. So put whatever thoughts you have down in the comments and we can talk about it there. Of course, in the meantime, you have all this code available to you in that link in the description right down below, rough edges and all, to experiment with the different architectures and see what you like and leave your thoughts in the comments down below. And of course, I'm always appreciative if you want to hit that like button and certainly that subscribe button and click on that bell and be notified the next time a new Blue Collar Coder comes out.